Hello dear friends, and welcome once more to this video today in our YouTube channel. In this video friends, we shall be looking at a question that is based on probability and probability tree diagram. So friends, stay tuned and make sure you watch the video from start to finish so you can have a clear understanding on how the concept looks like. So friends, this is one of those areas that most maths mechanics students and statistics students always have issue with it, but I promise to break everything as easy as possible friends. So friends, please don't forget to like the video as you're watching. That is going to motivate me to keep producing more great contents for you. Good luck to all those who are taking mathematics with mechanics and statistics. Good luck to all of you as you write your exams. So friends, if you're new to this channel, don't forget to subscribe to the channel so that you're going to be having all latest updates about all the contents we produce here. Thank you very much guys, and let's get started. Awesome friends, so as you can see friends, we have the question on screen. The first part was that two independent events A and B are such that the probability of A is 2/5 and the probability of A given B is 1/3. The probability of B given A guys is 1/2. We should find A the probability of B, and B the probability of A union B. Great. So friends, let's tackle the first part, then we shall talk about the other. So friends, the question wants us to get the probability of A, and the clue of the question is that they've told us that the events are independent events, and they've given us the probability of A given B and the probability of B given A, and as well the probability of A. So friends, let's make some observations. Let's observe that the probability of A given B guys is simply given as the probability of A intersection B all over the probability of B. Friends, this is conditional probability. Okay, it's a conditional probability. So friends, and in such a case guys, if you make probability of A intersection B the subject, we are going to have the probability of A intersection B that is equal to the probability of B times the probability of A given B. Great. So we can keep this one aside. Then friends, also we can also tell them that the probability of B given A is simply given as the probability of A intersection B all over the probability of A. Great. And similarly guys, if you also make probability of A intersection B the subject, we are going to have the probability of A intersection B to be given as the probability of A times the probability of B given A. Great. So friends, in this our equation, right, we can see that initially the probability of A intersection B here is given as the probability of B times the probability of A given B. Then now we also have the probability of A intersection B equals the probability of A times the probability of B given A. Great. So friends, in this case now, if we set the equations equal to each other, because this is the same like this as well is the same like what we have here, if you set them equal to each other, we are definitely going to have the probability of A times the probability of B given A equals the probability of B times the probability of A given B. So friends, you might be asking that how did I come up with the idea to make this guy the subject and make this guy the subject as well? It is because I don't have a value for the probability of A intersection B. Okay, I don't have a value for it, so I need to look for some way in which I can eliminate it from my equations. Good. And I finally done that. So friends, in this case, we make the probability of B the subject of this formula. Since it is our unknown from the A part, we are going to have the probability of B to be equal to the probability of A times the probability of B given A all over the probability of A given B. Great. And friends, you notice that we have the probability of A, right, which has been given as 2/5. Then the probability of B given A is 1/2. Then the probability of A given B is 1/3. Great. So if we plug in everything guys, we are simply going to have the probability of B equals 2/5 into 1/2, all that divided by 1/3. So if you simplify so well guys, we are going to have the probability of B to be the same like 3/5. Great. So friends, that's the answer for the first part. Then the B part is saying that we should get the probability of A union B. So friends, we know for sure that for independent events guys, we know that the probability of A union B is the same like the probability of A plus probability of B minus the probability of A times the probability of B. Great. Friends, we have the probability of A times probability of B because for events that are independent guys, the probability of A intersection B is the same like the probability of A times the probability of B. Great. That's why instead of P into A intersection B, we rather have but probability of A times the probability of B. Great. So friends, if we plug in everything guys, we are going to have of A union B to be the same. Like probability of A, we have it here to be 2/5. Then probability of B is what we calculated, which therefore means that if this our answer was wrong, means the one down also has to be wrong. Great. Minus the probability of A is 2/5 times probability of B 3/5. So guys, if we simplify so well, you'll see answer to be 19/25. Great. So that's the answer for the first part guys. Let's move on to the next part. Awesome guys, awesome. So friends, the next part start by saying that a spare part dealer receives spare parts from 3 different suppliers X, Y and Z, with 2/5 of the parts coming from X, 7/20 from Y, and the rest coming from Z. It is known that 2/25 of the parts supplied by X, 1/10 supplied by Y, and 1/20 supplied by Z are defective. If a spare part is bought from the dealer, we should find the probability that the spare part is C, because here was B, they've continued with C, defective, D either from Y or it is defective, then E from X, given that it is not defective. Great. So friends, to answer this question so well, that is to score all the marks without stress, it will be so good for us to come out with a tree diagram to to see the behavior of these various probabilities on the tree diagram. Okay, so let's come up with a tree diagram. So we are going to have the first branch. In this case, we are going to call it X. Okay, that's the suppliers, that is the X supplier. Then we are going to have this one, and we are going to call it the Y supplier. Then we have the last, which are going to call that the Z supplier. Great. So friends, we know that that from the question we know that 2/5, that's 2/5 of the parts were coming from X, right? That's why the probability of a part coming from X guys is 2/5. Great. Likewise, the question told us as well that the probability of a part coming from Y was what guys? 7/20. So we have it here, and the question did not give us that for Z, but we can get that for Z by simply taking 1 minus the sum of these two probabilities, and if we do that guys, we are going to have 1/4. Great. Then friends, the question also told us that it is known that 2/25 of the parts supplied by X, 1/10 supplied by Y, and 1/20 supplied by Z are defective. Great. So we are going to take capital D to represent the probability for a defective part, then D prime to represent the probability of a part that is not defective. Great. So friends, we are going to put that for X. We are going to have the last branch, which is going to be talking about the probability of having a defective part, which we have taken to be capital D, and this probability, as the question suggests, has is what guys is 2/25. Great. 2/25. Then guys, without any doubt, we are going to have the probability that a part is not defective, because they told us that of the parts that were supplied by supplier X, 2/25 of the parts were defective. That therefore means that there is some portion of the parts that are not defective. Okay, there is some probability of the parts that are not defective, and that is what we are going to get here. By so doing guys, we are going to take 1 minus the probability of having a defective part to get the probability of having the parts that are not defective. So if we take 1 minus 2/25 guys, we are going to have 23/25. Great. That's why we have it here. Then the question told us as well that 1/10 supplied by Y and 1/20 supplied by Z are defective. So let's have that for Y. We are going to have that for Y. We are going to have defective to get the defective part. The equation gave us as 1/10, and without doubt guys, the probability of having a part that is not defective, which was coming from the supplier Y, is not going to be 1 minus 1/10, and that gives us 9/10. Good. Then friends, similarly, 1/20 of the parts coming from Z were defective. Great. So we are going to have here to be 1/20. Then we know, without reasonable doubt guys, the probability of having a part that were still coming from Z that were not defective, we have it to be 1 minus 1 over 20, and we have 19 over 20. Good. So this is what we have, guys. So friends, keep in mind that after constructing this tree diagram, guys, it ends with no mark at this point. No mark has been earned because the question did not ask you to construct any tree diagram, so no mark has been earned. But all the marks you're going to score in this particular question depends on the success of you drawing this tree diagram. Like if your tree diagram is wrong, guys, you're going to lose all the marks if your tree diagram is wrong. Great. So friends, if the question had asked us to come out with their individual probabilities, we're going to say that that at this point, that is the first guy, we are going to have the probability of having a, we are going to have the individual probabilities as we have here. We are going to come up with our arrows to indicate the various probabilities we have. Then guys, coming up here, we are going to say that this is the probability of a part coming from X that is defective, probability of a part coming from X again that is not defective, that is D prime. Then we have the one that is coming from Y and it is defective, from Y not defective, probability of a part coming from Z that is defective, and the one coming from Z that is not defective. So this is we have simply sampled the individual probabilities. Good. So friends, let's now start scoring the marks. They want us to find the probability that a part that the spare part is defective. Now friends, we should know that the question did not tell us, did not specify the supplier. Okay, so we are going to consider all the cases. So to get the probability of having a defective part, the defective part can either come from supplier X, supplier Y, and supplier Z. So we are going to examine everything. So we are going to have the probability of a part coming from supplier X that is defective, plus that coming from Y that is defective, plus one coming from Z that is defective. Great. So if we plug in everything, guys, coming from Z and coming from X, we are going to have the probability of a part coming from X first of all, then that it is defective, we have 2 over 25, plus friends the probability that is coming from Y, that is 7 over 20, that times the probability that it is defective, we have 1/10. And we'll do that for Z, guys. Similarly, we're going to have 1 over 4 into 1 over 20, guys. And simplifying everything so correctly, guys, simplifying this way, we're going to have answer to be 159 ordered over 2000. Great. So that's the answer in this exact form. So friends, don't simplify and put your answer in decimal form. Okay, the answer in fraction is okay, unless the question specifies, and the question will tell you the number of decimal places. Great. So friends, the D part wants us that to get the probability that that the part comes either from Y or that it is defective. Great. Guys, a clue of this question is the word or. Okay, or in probability simply means what? Union. Great. So we are definitely going to have for the probability of having that is the part came either from Y or it is defective. Great. So by default, guys, it is going to be the probability of a part coming from supplier Y plus the probability of having a defective part, that is this inclusive guy. Okay, this defective here, guys, is not the same as the one we have here. Okay, it's not the same like the one we have here. So we are going to have the probability of it coming from Y plus the probability that it is defective, that is of having a defective part, minus the probability that it comes from Y because it is defective. Great. So friends, we know that these events in this case, after drawing our tree diagrams and seeing them in this case, guys, they are independent events. Okay, so in such a case, guys, we are going to multiply the probability of A of Y intersection B of Y intersection D. Sorry, we're going to multiply the two probabilities. So guys, plug in everything, guys. We are going to have probability of the part coming from Y. We are going to have 7 over 20. That is, this is it here, guys, 7 over 20. Plus now, guys, this probability of having a defective part is 159 over 2000. Okay, it's what talks about having a defective part in general, not that it is from Y. The one that is talking about only from Y is the second one. Okay, this is it here. This is it that comes from Y. This is it, guys. As you can see, 1 over 10. Great. So friends, simplifying everything, guys, we are going to have our answer to be 789 over 2000. Similarly, guys, then the last part is saying now find the probability that it came from X, given that it is not defective. Great. This is a conditional probability, so we are going to have the probability of it coming from X, given that it's not defective, to be the same like probability of having a part coming from X because it is defective, or that over the probability of having I'm sorry guys, the probability of a part coming from X given that it is not defective to be the same like the probability of a part coming from X because it is not defective, or that over the probability of not having a defective part at all. So friends, keep in mind that the one we have in this denominator, okay, though I've written them in the same way like the one at the top, they are not the same. The one at the bottom is 1 minus this value, okay, then one at the top is the probability of having a defective part because it came from X, or of not having a defective part, sorry, because it came from X, and that's the same like 23 over 25. Good. So friends, if we plug in everything guys, we are going to have probability of having a part that came from X, which is 2 over 5, times because times the probability that the part was not defective, that is 23 over 25, all over the probability of not having a defective part, that is 1 minus the probability of having a defective part. So friends, if we simplify so well, we are going to have our answer to be 736 over 1849. So friends, this is the answer we have. This is what we have. So friends, thank you very much for watching the video, and put your worries in the comment section down below if there's something you didn't understand. I'm going to explain as soon as possible guys. I don't take so much time to explain. Guys. Once you post your problem, it is answered automatically already. Okay, I answer it as quick as possible. So friends, thank you for watching, and like the video please. If you're not subscribed, subscribe so you're going to have access to all our great content. Thank you very much, and have a blessed day.